Herkese günaydın. İsmim Deniz. Daso Sistem'de pazarlamadan sorumluyum daha doğrusu. Webinarımıza hoş geldiniz. Bugünkü webinarımızı iş ortağımız Kadem'le birlikte yapıyoruz. Webinarımızın konusu Robotik Simulasyon ve Sanal İkizler ile Dijital Üretimin Geleceği. Bugün sizin için oldukça kalabalık bir ajanda hazırladık. Öncelikle vaktinizi ayırdığınız için çok teşekkürler. 4 ayrı ülkeden sunumla bugün karşınızdayız. Türkiye, İtalya, İngiltere ve Fransa'dan dijital üretim uzmanlarımız bugün sizinle birlikte yaklaşık olarak 1-1,5 saat geçirecekler ve bu süre zarfında size dijital üretimin geleceği ile alakalı bazı bilgiler vermeye çalışacağız. Şimdi çok kısaca size ajandayı göstermek istiyorum. İlk olarak Kadem Dijital'den Ali Çelik'le kısa bir giriş yapacağız. Daha sonra Ervan Oliv bize sanal ikizlerin geleceği ve sanal ikizlerin günümüzdeki durumu hakkında kısa bir bilgi verecek. Daha sonra Damiano'nun, Karpim ve Adriano'nun sunumlarıyla da dijital üretimin detaylarına daha fazla girmeye çalışacağız. En sonunda bir soru-cevap oturumumuz olacak. Eğer sorularınız olursa yan taraftan yazarsınız bize, memnuniyetle cevaplamaya çalışırız. Çok teşekkürler tekrar katıldığınız için. Ben şimdi sözü Ali Çelik'e bırakıyorum. Kendisi bize kısa bir sunum yapacak. Ali Bey, lütfen başlarsınız.
Teşekkürler Deniz. Kontrollü bir test ediyorum öncelikle. Sayfayı değiştirebiliyor muyum diye. Şu an için değiştiremiyorum. Deniz, kontrolü verebilir misin?
Şu an değiştirebilirsiniz.
Teşekkür ederim. Öncelikle ben de tekrardan herkese merhaba demek istiyorum katılımlarınız için. Umarım çok faydalı bir webinar olacak. Çok özel bir webinar olduğunu düşünüyoruz bunun. Çünkü son yıllarda biliyorsunuz dijital dönüşüm oldukça önemli bir aşamaya geldi ve hemen hemen tüm firmaların belirli seviyelerde odak noktası halinde ve bazı firmalar belirli aşamalarda ilerlemekte. Bazıları da nasıl yol alacaklarını veyahut da dijital ikizin tam olarak ne olduğunu veyahut da bunu nasıl yönetecekleri konusunda araştırmalar içerisindeler. Bu seminerimizde, webinarımızda da özellikle bu konularda oldukça faydalı bilgilendirmeler olacağını şimdiden taahhüt edebiliriz. Umarım herkes için faydalı olur. Webinara başlarken kısaca Kadem'den başlamak istedik. Kadem kimdir? Kadem Dijital kimdir? Ne yapar? Kısaca onu aktarıyor olacağız. Kadem Dijital, belki Kadem Dijital ismi 2020 yılında kurulmuş ve spin-off olmuş bir firma Kadem Dijital. Ama herkes Kadem Dijital'den ziyade Kadem şirketin daha çok aşina ve bilindik bir şirket olarak herkesin daha çok akıllarında. Daha çok aklımda. Çünkü Kadem yaklaşık 20 yılı aşkın sürede otomotiv, havacılık ve makine endüstrisi ağırlıklı olmak üzere faaliyetlerini sürdüren bir firma ve 20 yılı aşkın sürede özellikle DASO sistem çözümleri üzerine firmalarına çözümlerini sunan, eğitimlerini gerçekleştiren ve gelişimlerinde destek olan bir partner olarak 20 yıl aşkın süredir faaliyet gösteriyoruz. Şu anda 4 farklı şehirde bulunuyoruz. Bunlardan bir tanesi İstanbul, diğeri Ankara, bir ofisimiz İzmir'de var, diğeri ise Bursa. Merkezimiz İstanbul olmakla beraber ağırlık olarak faaliyetlerimiz Bursa'da otomotiv yoğunluğundan dolayı ve makine endüstrisinde yoğunluğundan dolayı ağırlıklı faaliyetlerimiz Bursa içerisinde ama 4 farklı şehirde diğer tüm şehirlerdeki kullanıcılara ve firmalarımıza hizmet etmeye devam ediyoruz. 35 kişilik bir ekibimiz var. Bunlar 35 kişilik ekibimizin büyük bir çoğunluğu mühendis ve yüksek lisans seviyesinde arkadaşlarımızla bu hizmetimizi devam ettirmeye çalışıyoruz. Yaklaşık 350'nin üzerinde aktif müşterimiz olmakla beraber binin üzerinde de aktif kullanıcıya bir fiil destek veriyoruz kullandıkları çözümler doğrultusunda. Tabii ana partnerimiz ve vizyon ortaklığı yaptığımız partnerimiz Dasosystem firması. Dasosystem firmasıyla beraber yine bahsettiğim gibi 2000'li yılların başından bu yana, yani 1998 yılından bu yana çalışıyoruz. Versiyon 4'ten bu yana. Tabii Dasosystem'in çözümlerin geldiği bu seviyeyle beraber artık 3D Experience platform üzerinden faaliyetlerimizi ve firmalarımıza olan hizmetlerimizi devam ettiriyoruz. 3D Experience platform bugün sunumların devamında dinleyeceğiniz sanal ikiz çözümlerinin de üzerinde koştuğu bir iş platformu aslında. 3D Experience platform dediğimizde geleneksel olarak bildiğimiz Dasosystem'in Katya, Enovia, Exelit veya Similia gibi ve bugün ağırlıklı konumuz olan Delme gibi çözümlerin markaların altında bir omurga oluşturan ve bütün bu markalar arasındaki veri sürekliliğini, data sürekliliğini sağlayan, aynı zamanda dijital süreklilik anlamında firmaların çözümlerini veyahut da süreçlerin merkezine oturan bir platform. Doğru datayı doğru zamanda doğru kişinin erişmesine, işlemesine ve işlerin yürümesine olanak sağlayan ve kesintisiz bir dijital süreklilik sağlayan bir platform, dijital 3D Experience platformu. Biz de bu 3D Experience platformu içerisinde bütün markalar üzerinde firmalarımıza hizmet veriyoruz. Tabii ki bugün önemli olan şey özellikle Delmia markasındaki sanal ikiz çözümleri. Biliyorsunuz son zamanlarda dijital dönüşüm oldukça revaçta, söylediğim gibi. Firmalarda sanal ikiz nedir? Bu nasıl devreye alınır? Bunu derinlemesine anlayıp firmalarında uygulamak istiyorlar. Otomasyonun da gelişmesiyle beraber robotik simülasyonlar da bu halkanın önemli bir parçası. Bu webinarda da bu konularda derinlemesine bilgilere sahip olacağız webinar sonunda. Dediğim gibi 20 yıl aşkın süredir Dasosystem'le beraber çalışıyoruz ve Dasosystem'in son dönemlerde uygulamaya başladığı platin partnerlik nişanını 3 yıldır ard arda sahibiz ve bu manada verdiğimiz hizmetin ve eğitimlerin kalitesi Dasosystem tarafından itinayla takip edilmekte ve geliştirmesi yönünde destek verilerek bunlar izlenmekte. Bu manada da müşterilerimize verdiğimiz hizmetin kalitesini garanti altına almış oluyoruz. Sunumun bundan sonraki aşamasında da biraz daha artık Delmia çözümlerine ve sanal ikiz çözümlerine doğru ilerliyor olacağız.
Ali Bey çok teşekkürler sunumunuz için. Şimdi Ervan'ın sunumuyla sanal ikizlerin bir genel görünümünü öğreneceğiz. Sunumun bundan sonraki kısmı İngilizce olacak. Eğer herhangi bir sorun yaşarsanız bize bildirebilirsiniz. Etkinlik sonrasında önümüzdeki hafta içerisinde Türkçe altyazılı versiyonu da tüm katılımcılarımızla ve kayıtlı kullanıcılarla paylaşacağız. O yüzden herhangi bir sorunuz olması durumunda bize ulaşmanız yeterlidir. Erwan, the stage is yours. Can you present?
Yes, thank you, Denis. Hello, everyone. So my name is Erwan Olive. I'm working for the Delmia brand of Dassault Systèmes, which is a manufacturing division of Dassault Systèmes. I'm working for all Europe, Middle East, and Africa countries, working together with our partners like Cadem today for Turkey. I'm going to introduce what is the virtual twin, how we can work with a virtual twin. So I will try to put some definition for you so that you can really understand what are the capabilities of our solutions. So it is only an introduction. It will be very quick. And then Damiano and Kartik will present you more in details those informations. So let's go through this introduction. So what is virtual twin? First, we don't say virtual twin at Dassault System. We are talking about 3D experience twin. So what is the 3D experience twin? First, okay, you understand that we are working on the 3D experience platform, which is our software solution able to merge the manufacturing domain with the CAD engineering domain, also with the simulation and also PDM system, all in one single solution. So this is for 3D experience platform. Then for 3D experience twin, what is it? It is in fact a virtual model of your manufacturing system, and this manufacturing system can be a work cell with one robot or a special machine, for example. It could be a complete manufacturing line. So in this case, you will have several robots, several machines linked together. It could be also, why not, the entire plant with all your production system inside working in a virtual world. So the idea of this 3D experience twin is to make your manufacturing system alive. So now we are going to show you how we are doing that. So first, why? What for the 3D experience twin? So first you have to know that making a 3D experience twin is dedicated to two kinds of users, two kinds of customers. The first kind will be a production company who need to see their manufacturing line in a virtual world to be able to check, to be able to do some modification in a virtual world before making modification in the real world. So our first use is production companies. But we have also a second kind of user. We have also some companies who are building some manufacturing line or who are building some work cells. So for those people, we can propose a tool to define, to help them in defining their new work cell or new manufacturing line, so that they can optimize all the things. So why do we create a 3D experience twin? The first idea for sure is to save time, cost for our users. The idea is to be able to make better decisions before doing some modification in a manufacturing line, because here we are talking about new manufacturing line, but also we are talking about existing manufacturing line for which we would like to do some modification, for example. The idea is to check everything virtually before applying those changes in the real world. Okay, so the idea is to check new product introduction. For example, if you have to adjust the manufacturing line for new product, you can check that in the virtual world. The second use case is you want to accelerate the production. Before doing that, let's check in a virtual world just to identify bottlenecks, for example, and try to optimize virtually before doing it in the real world one more time. The idea also is to, why not, improving the setup, the layout of a production line. So before moving any machines, let's move them in the virtual world just to be sure that we will have a better production system with the new positioning of the machines. And the idea also is to try to eliminate errors and problems which could happen when you make some change in the manufacturing. So those are some different ideas on why we are using a twin to try to improve our production system. Now, I would like to introduce some words about how we create a 3D experience twin. So in fact, Damiano and Kartik will show you how we can do that, but let's introduce the idea. So how we create a 3D experience twin. So you understood first that we are using the 3D experience platform to do that. With the 3D experience platform, we are able first to plan operations. So here, in fact, we are talking about listing all items I need to start my production, for example. So here I will define a manufacturing bill of material. I will also define each operation necessary to build my product. So here, in fact, I'm defining my manufacturing operation thanks to the 3D Experience platform initially. So with those information, I can feed the ERP system, but I can also feed the next step of my twin that are first the layout of a plant. So if I know each operation I need to build a new product, I can display those operations inside the virtual plant, and I can then do some studies thanks to the next steps that I will show in the next seconds. But before that, about plant layout, the idea is to use some data that are existing, and those data can be different, and I can mix them into the same view. What do I mean? In fact, with the layout, I can import some 2D drawing if we have 2D drawing of the factory. I can also import some CAD information for a specific machine coming from some providers. I can also use my own CAD data that are coming from my engineering office. So the idea of the plant layout here is to mix different sources of data into the same screen and to have a 3D and 2D layout of my future plant. Then next step, once I have my virtual plant in this 3D environment, I can do some simulations. And here we are talking about machine simulation because we can define some kinematics on whatever, on some machines, for example. And also we can do some robotic simulation as we are also providing a catalog of robots. The most common on the market are available in this catalog, which now I think we have 2,000 robots in this catalog currently. So we can do machine simulation just to check reachability, accessibility, to avoid the clash with the environment. So this simulation is done independently for each work cell. And then the last step of a twin is to be able to simulate the entire line. So we can really display our manufacturing system really alive in our twin so that we can check the production rates, we can get some KPIs and take some decision in changing something if we want to improve the way it is producing. So the idea is to satisfy the three pillars that are efficiency, performance, and innovation, and this is the 3D Experience twin. For the next speakers, we will introduce you only the plant layout and machine simulation, and factory simulation. Just coming back, I'm trying to come back. Okay, so in the next step, we will present you plant layout, machine simulation, and factory flow simulation. The main topic for sure is robotics, but you will see that to do some robotic simulation, we need the layout, and we can also, from the robotics tools, we can also switch to the factory flow simulation very easily, thanks to the 3D Experience platform, which is proposing every domain in the same screen, in the same software. The benefits of this twin, first is to, for sure, lower cost. Okay, how to lower cost? The idea is to generate and to do a faster development. Okay, the idea also is when we have a new product to introduce is to be simply on time to deliver. Also, this kind of system enables you to increase the safety by doing some studies on the workstations for workers and ensure that everything is accessible for the workers and so on. So thanks to a virtual world, we can do this kind of study before starting the production. And then more globally, if you have to build some new plants, you can reduce the footprint in the environment by optimizing also the way this new plant will be installed. So those are different benefits and there's many more that are enable people to improve the way they are producing. And also it is an excellent way to present a solution for line builder companies that are making this kind of production line or simple or machines. To finish, this is my last slide. A simple case study which is showing very strong numbers. Here we are talking about Centerline. It is a Canadian company, so they are based in Canada, but they have also a plant in Romania here in Europe. They are building some robotics work cells, and thanks to the 3D Experience robotic solution, they could really reduce the time to market their solution and reduce potential errors. So instead of making the real robotics work cell in their plant to do some tests and to ensure that everything is okay, they are doing all tests virtually before building their work cell only one time. So they are really reducing their delivery time because they are doing all studies virtually thanks to the 3D Experience robotics solution. And they can also use some specific application, like in this example, they are talking about arc welding, where they are able to check the robot torch angle and to satisfy what the customer requested exactly, because the customer requested exactly the right angle to be used by their provider. You will be able to find those Centerline testimony on YouTube. You simply can type Centerline and Dassault, and you will find easily this video and the sound associated to this video. Okay, so that's it for this short introduction. Let's go to the next slide. And now I'm going to transfer the speech to Damiano, who will develop the plant layout domain and also the flow simulation domain. So Damiano, it is your turn. You are on mute.
Okay.
Yeah. Okay.
Yes, can you hear me?
Yes, very well, thanks.
Okay. Good morning to everyone. My name is Damiano Nardi and I work as an industry process consultant for Dassault Systèmes. I am based in Italy, but I support all Euromed activities, including Turkey. So my goal is try to introduce the concept that Erwan explained before related to the production line definition topic. And then Kartik will go in detail to explain robotic simulation and virtual commissioning, that is the core of today actually. So let me make a step back and reconnecting to what Erwan was saying. When we talk about 3D experience, it is a very wide platform that enables all digital manufacturing activities. So it means that if you are an existing CAD user, like for example a CATIA V5 user, it means that you can use this CAD data and maintain your CAD investment to use all the 3D experience applications to enable digital manufacturing. This means that you can use your CAD models to do plant layout activities or robotics or machining or process engineering. So that's the very important step from which we have to start, so we can leverage your existing CAD investment. But then, if we talk about production line definition, we know that there are several steps that have to be performed and several business processes. So we are able, with the 3D experience, to cover basically all the business activities that must be done to design a production line. So we can support R&D to create a library of equipment and a standard solution. And so once a new equipment is designed, it can be validated virtually and inserted, for example, in a standard library. Then we have the possibility to support the engineers during the line conceptual design. So for example, during the RFQ phases, so the line definition, we can define the 3D plant layout, we can define and simulate the resources and the material flow to validate, at least on a general way, our line, to say that this line will be able to satisfy the customer requirement and win the deal. And then once the deal is win, we can start to do line detailed engineering. This means that we can start to do mechanical, electrical, and software design, and in particular, robot programming. That is the core of today. But please consider that we're able to cover all these kind of business processes, so like virtual commissioning, and then all the part related to installation and in service. Okay, but the idea of today is to focus on some just of these business processes, and in particular, I will focus on this part. So the green one, like related to plant layout and material flow simulation, while Kartik will focus on line detail design and virtual commissioning. So that's the idea of today. So let's start from the typical challenges of line builders. Okay, so first of all, the market is asking to deliver flexible line with the right level of performance, to improve the technical tender through the bidding process, to reduce the misunderstanding between sales and customer, and to ensure the digital continuity between the sales and the engineering activities. So to overcome these challenges, we can propose some 3D experience application to help people and engineers and sales to do their job better. So the first app is Plant Layout Engineer. This is an application that allows engineers to position and manipulate resources in 3D, to work in a full 3D environment, but starting, for example, from 2D drawings. And we have the possibility to manage catalog of resources that can be also parametric. And so the kind of values that this application can bring to you is the possibility to access the layout data through the extended enterprise, to define your layout in a fast and efficient way. And then, very important, since we are in a collaborative platform, we can enable collaboration between the different engineers, the sales team that have to collaborate to develop the plant, and very important, to leverage the intellectual property of the company. So we can create libraries, a standard solution that can be reused across different projects. So now let's start to see the functionalities of this application. The first one is related to the possibility that we have to build our 3D model starting from a 2D. So in this case, we are importing an existing DXF file that maybe could be provided by our customer. And so first of all, what we can do is starting from the 2D to insert additional information using the sketching tools that are inside our platform. So that's the first point. And then we can start to building the 3D layout. So the first thing that I want to underline is the fact that we have the possibility to manage a catalog of resources. So as you can see in the picture, we can organize our intellectual property inside several catalogs that can be reused easily across different jobs. So we do not have to reinvent everything every time, but we can reuse across different projects. And so you can see now in the video, okay, how it is easy to, starting from the 2D that we have imported before, to build the 3D layout. So for example, you see the structure of the layout. Okay, we have several folders and we have organized our resources according to different criteria. So we have tools, we have storage, infrastructure, we have robots and so on. And right now we are starting to build the layout, adding the fences to our plant layout. Okay, so you see how it is easy to insert from the catalog the resource more than one time. So just using in few clicks, we are able to start building the layout. And then if we have a catalog of parametric resources, we can modify the parameters that are available. So in this case, I am modifying some parameters related to my fence. And then thanks to some tools that improve the productivity of the plant layout engineers, we can, for example, exploit the properties defined on the 2D layout to position easily all the 3D resources and, for example, connect them easily themselves. So the other important thing is that we can generate the layout structure. So it means that basically we can create the bill of material, the bill of resources of our plant Okay, so this would be very important, for example, for cost estimation activities. So in this case, you see that I can say how many resources I have in my bill of material of the plant, and I can manage several attributes, for example, the purchase cost, but it can be every kind of attribute that can help people to estimate which will be the cost of my plant, for example. And then you see we can continue the definition of our 3D layout, for example, inserting some buffers, okay? And then we have some tools, again, to avoid mistake. For example, we can use dynamic clash detection to position the 3D models, being sure that there is no clash between the resources that we are positioning, basically. So this is related to the first step, and you see that we are start building our 3D layout. Then we can go on inserting other kind of resources. And first of all, this is a very important topic because then Kartik will connect to that. We have the possibility, oh, sorry. Let me see. Okay, some lag, sorry. Okay, we have the possibility to leverage, as Erwan was mentioning, a catalog of existing robots that are already kinematized with the 3D geometry, and they are ready to use to do robot programming. So in this case, you see that we are continuing the development of our layout, and we are existing, for example, this robot from ABB. But again, we have all kind of robot vendors inside the platform. So you see that now it is easy, for example, to replace this robot with another one. So we have, again, a sort of tools to improve the productivity of the plant layout engineers. So you see that we can position the robot. We have the 3D model of the robot that will be used later by Kartik to do a robot simulation. And then another important feature that we have is the possibility to create pattern of resources easily. So in this case, you see that we are continuing the layout definition, adding the conveyor to our line. Again, this conveyor is a parametric resource, so we can modify, for example, the parameters related to the dimension of the conveyor. And then, as you can see, we can create easily patterns. So we can decide how many times we want to repeat this item, for example, specifying some offset between the resources, and then we can decide, for example, to snap them. But again, we have a lot of tools and we cannot see all of them because of a matter of time to improve the productivity of the plant layout engineers. The last point that is very important, in my opinion, is related to the possibility to handle point cloud. So we have the possibility to import. Oh, sorry, there's some lag again. Okay, as you can see, we can import, for example, scan activities. What happened? Okay, to import existing. I don't know if someone is doing something. Okay, because I'm not touching my mouse. Okay, but again, I was saying you can import your point cloud inside the 3D experience, so the scan of your existing line, and this is very important in case of revamping activities or modification activities. So you see here we are exploring the 3D model that we have imported, so the point cloud that we have imported. And then very important, we have the possibility to create an hybrid layout composed by point cloud and the 3D models that we have defined so far. So again, this is very important in case of revamping activities. So that's all for the layout definition. And then before passing the ball to Kartik, I will introduce another role that is industrial engineer. This is a role that, as I was mentioning before, it is very important because it allows you to simulate your production line in the context of the execution of the production plan that will be executed on the line. So what we can define is the material flow and the resources simulation, and we can perform discrete event simulations. So we can leverage this kind of simulation engine, and then after the definition of the routings of our product, some parameters related to buffer capacity, transfer time, the property of the conveyor system like the speed of the conveyor and so on. We can simulate our production plan and we can see the result. So basically, we can see if our line or our cell will be able to satisfy the customer requirements in terms of productivity. So that basically, we can evaluate the throughput of our line. And since we are in virtual, we can perform several what-if simulations. So the value that we can bring with this kind of application is the possibility to validate the behavior of a station, a line, or a complete plant, and we can detect and alleviate bottlenecks to validate early the manufacturing process plan in the context of the line that will execute this manufacturing process plan. So you see here in this picture, we can, after the creation of the behavior and the simulation, we have several KPIs that can be analyzed by the industrial engineers, and then they can perform several what-if scenario, and then they can come back and decide according to the result of the simulation to improve the layout of the plant or maybe to modify the routings of our product. And at the end of the day, this will help to demonstrate to our customer that our cell, our line will be able to satisfy his requirements in terms of productivity. So here we have a very simple example in which we start from a plant layout defined before in 3D. And let's see the example right now. Okay. This is an example of an assembly line in which we have both manual and automatic operations. So in this case, the assembly line is assembling some seats, and you see that we have two different variants of this seat. The standard one, that is the yellow one, and the premium one, that is the brown one that is in leather. So you see that we have 6 manual stations of assembly, plus the robot that will perform the ending operation at the end. But again, this is just a simple example. And you see here all these blue and gray arrows are the product flows that happen inside our line. So we have defined the product flow, and for each station, we have defined which are the operations that will be performed. And then, according to the discrete event simulation activities, we can define which are the input and the output of the station. We can connect the 3D models, as you can see, and this will be very easy, for example, to communicate with your customer and to explain to him which will be the behavior of your line. And again, we can assign the resources because this kind of engine is simulating at finite capacity. So it's considering the resources utilization that is very important, again, to identify bottlenecks. And then we can define the parameter of the buffer, like the capacity. And again, I was saying we can manage a complex production plan, explaining the fact that we can have on the same station 2 different assemblies activities, one related to one variant of your product and the other one related to another variant. So in this case, you see the standard and the premium seat again. So we can manage this kind of complexity. And again, we can always connect the 3D model because we are in the 3D experience, and we believe that the 3D model is a universal language that can be understood by everyone. So now you see that we can define the input for each station, and we can define the schedule. So we can basically specify which will be the production plan that will be executed. So which are the lot that will arrive, which is the lot size, which product will be assembled. So we can define basically our schedule that will be executed by the discrete event simulation engine. And then, as I was saying, in this case, in our line, we have an automatic operation that is the handling operation of the finished product from the conveyor to the buffer. And we have specified that this robot will perform this activity. At this stage, we are not programming the robot. We are just analyzing the productivity of our line. And then Kartik will show you how to program this robot. But another important thing related to discrete event simulation is the possibility to consider the failure of our resources. So in this case, we can define for each station, which is the mean time between failure, the mean time to repair, which are the resources that are in charge of the repairing activities. And during the simulation, the discrete event simulation engine will take into account that according to a certain distribution probability, for example, a failure will happen, so the operator will stop the assembly process and will start to repair, and so the line maybe will stop because the resource is not available. So we can demonstrate to our customer the robustness of the solution that we are developing. And then once we have defined everything, we have the possibility to analyze the factory flow status. So we have a series of tools that helps the industrial engineer to be sure that everything has been defined in the proper way. So no mistakes during the design of the line has been done. And then we can simulate again using the discrete event simulation engine. So the simulation is starting. So you see here that we have a little bit of animation that can be used also to show to our final customer how the line will behave. And then in real time, we can see the basically the state of our resources. So graphically, we can see all the resources that are involved, for example, human, machines, buffers, and so on. And we can see in the legend if the resources is working, is waiting to input, waiting for output, and so on. So we can understand immediately if the line is well designed or not. And again, we can see that in real time using the 3D animation, or otherwise we can launch batch simulations with several parameters, and we can just have a look at the result basically. But again, you see here in real time, it's very powerful to see the result. So once the simulation has finished, we have a series of KPIs to see which is the resources utilization, which is the storage utilization, which is the mean time of the operations, which is the traveling of the conveyor and of the resources. So we have a huge number of KPIs that we can analyze and see if the line or the cell or the plant that we are designing is working properly or not. And then we have possibility to export this kind of results to Excel file and so on. So just to conclude before passing the word to Kartik, we have seen two applications, one for the definition of the 3D layout and the other one to perform an early simulation of our production plan applied to our plant. So the benefits that we have seen are related to the possibility to define your layout in a fast and in an efficient way. You can save time and money by designing and validating in 3D. You can improve your customer experience because if you design everything in 3D, again, 3D is the universal understood language, so your customer will understood easily what are you designing for him. You can reduce the constraint on the investment by validating the line concept very, very early. And you can improve your manufacturing line's performance by optimizing the use of the resources and of the process. And finally, you can test several production scenarios to improve your line flexibility and your line robustness. So that's it for my part, and I will leave the stage to Kartik, and if you have questions, don't hesitate to ask at the end of the webinar. Thank you.
Good morning. My name is Kartik Kumar. I'm industry process consultant. I hope you can hear me well. Okay.
Yes, I do.
We can hear you.
Perfect. Yeah, so my expertise is in robotics and virtual commissioning, and I am based in United Kingdom, but I work on most geographies in Europe and specifically in Euromed and Euro-North. So to give you a brief introduction into the robotics world, some key findings or statistics that we are noticing from recent industry trends is that from year 2020 to 2022, there are close to 2 million industrial robots expected to be installed around the world. And also we are noticing a trend where, because of this pandemic like COVID, Corona, most of our applications will be automatized using robots in the near future. And another trend which I would like to highlight is the use of cobots, where robots and humans will be working together. In the traditional application areas where we use robotics in industrial applications is spot welding, arc welding, material handling, and surface handling, or how we do the paint and do some sealant application using robots has been predominantly a very well used applications. Some of the trends, use of cobots, where you have the human assist, where the human and the robot will be working together. Autonomous robots, where robots are installed on an AGV, and you give an autonomous robot some task and he will execute it without much of intervention. Use of vision and sensors, more IoT sensors have been used. Machining and additive manufacturing using robots. In the aerospace industry, a lot of drilling and riveting using robots, and also companies have to be cognizant of the fact that robot energy efficiency, or how much power we are consuming when we actually turn a manual application into a robotized application, are the key trends of industries today. Moving to the next applications. Okay, oh, sorry, there is a lag.
Karthik, do you want to present the previous slide?
Yeah.
Yeah.
So
okay.
To simulate and validate an industrial robot behavior, we have something in app called a role called Robotics Engineer, where we use a catalog of more than 2,000 robots, industry ready robots with all kinematics defined and the soft limits and the hard limits, where we use robots for simulation for material handling or assembly scenarios. In this example, you will see there is a dual arm robot where we are doing assembly activity. You can see there is a light screen or a sensor. As the human will enter into the light screen, the robotic simulation will stop. This is an I/O exchange between the equipment and the robot, and this is used predominantly in small electronics manufacturing industries. And we have seen some traction how humans and robots will work together in this kind of environment. And there is not mere simulation that we are doing. We are having industrial robots I/Os exchange between equipment and between two robots. Moving to arc welding, this is the one of the key topics which I would like to explain. A lot of companies will have in the engineering define the bead fasteners, but in some cases we will not have a fastener defined in the engineering drawings where the weld has to happen. So 3D experience platform robotics arc welding simulation provides you the ability to select two intersecting surfaces and a seam will be created automatically. And all the arc welding parameters such as the rake angle, the angle of approach, the angle of departure, the deposition thickness, all this can be simulated so that we can generate a collision-free good robot program at the end of this exercise. Moving to next, which is the robot spot welding and drilling and riveting operations. This is very commonly used where we have a library of weld guns within a company where we have used for a previous project or some new project. So what we will do is we will analyze the right weld guns and the payload of the robot and then the reachability, and then we simulate where we balance the spots between the robots. And how do we balance this is by using some intelligent algorithms within the 3D experience platform, where we do the tool analysis where the system will automatically balance. And the same goes for drilling and riveting process used in aerospace and defense companies, where we have the robot placements and two robots working in parallel, where they have to drill and rivet together. So in the left-hand side, you will see the drilling robot, and the right-hand side, you will see the riveting robot. So both will work together at the same location. Some use case steps that I would like to explain when we go on a typical spot welding project. The product and the process will be prepared by the OEM, or it will be given to us as an industrial engineer. Then we instantiate the resources from the library. We have more than 2,000 readily available robots, and fixtures would be imported from any XCAD. You could have CATIA or any other CAD systems. We could get the fixtures. Once we have the robots and the fixtures with the panels, we will start to do the gun analysis, where the system will analyze within your library, if you have some 100 robot weld guns, which are the good weld guns based on the geometrical reachability that are applicable for this particular welding process. Once we have it, we will generate a robot trajectory from a robot simulation. With the robot trajectory, we will have a robot simulation where we have multiple robots, where the inputs and outputs, the binary signals, are used between the robots to communicate or synchronize, to make sure there is no collision between the robots. Once we are happy with the simulation takt time, the simulation speed, all the soft limits, hard limits of the robot, with the acceleration, deceleration in the simulation tool, we will generate a program download, which will be later. I will explain you about the offline programming. And moving to the simulation of painting and surface-based applications, we can easily generate robot trajectories to synchronize motion between the moving rail object, where in this example the car is moving. In some examples, the robot is also moving, where the robot is on the rail. And we have the graphical representation, where we see the deposition thickness in microns with respect to the electrostatic painting. All the paint parameters, such as the nozzle parameters, such as the paint speed, the viscosity of the paint, the temperature, everything is considered in this robot surface simulation. One of the interesting trends that we are noticing in the industry is the idea of optimizing robotic trajectory using some intelligent algorithms. In 3D Experience platform, we have this robot planning, path planning algorithm, where you will see if there is a collision between the robot and the let's say fixture in this example, or the clamp, the algorithm will automatically create wire points in the robot task, where you will make sure you will not have any collisions after this algorithm is finished. Now you see there's a new task where you will see automatically the program will modify the trajectory, and you will not have any collisions in the simulation. Import and export of robot programs. So the idea of generating a robot program which can be used in a robotic cell before commissioning is more important. And the idea of importing an existing program in the shop floor. Let's say you have done a project, one project where you have the robot programs already. It could be any vendor, Fanuc, ABB, KUKA. All these programs can be uploaded into 3D Experience platform to validate the current behavior. And if there is a modification, we can modify these programs in 3D Experience platform, and then download the program from 3D Experience platform and send it to the real shop floor. And to have an interaction between the real world and the virtual world, there is something called the translators that we use, where the neutral natural language from the Dalmia 3D Experience platform is converted into robot-specific languages, which, for example, Fanuc has got his own syntax and keywords. KUKA will have its own keywords and syntax. All this is translated from the 3D experience platform so that the customer doesn't have to spend more time analyzing it in the real shop floor. There is an important concept when it comes to robotics called RCS or RRS, the realistic robot simulation. So I would like to take a very quick minute to explain the difference between the RCS and the RRS. RCS is nothing but the software that is given by the robot vendor, and RRS meaning realistic robot simulation. When we do the simulation with 3D experience platform, or when we do the simulation, all the motion parameters is proprietary Dassault systems, where we use the acceleration, deceleration, or the machine data, the so-called in the industry, we call it MADA. All this information is used using the Delmia motion controller. When it comes to getting a realistic robot simulation where we have to get accurate motion and accurate cycle times in the trajectory, we use RRS. RRS can be of two types, RRS1 or RRS2. RRS1 is industry standard, where we use only the motion and the kinematics, nothing else. But when it comes to RRS2, we take the native program, whatever is in the shop floor backup, we take that as an input. We interpret everything in the motion, and the IOs are also considered. Dassault Systems 3D Experience Platform robotics applications supports both RRS1 and RRS2. So why should we do the RRS? Important question. When we have to get an accurate cycle time, when we are going to do a complete line definition, and robot vendors will provide their own programming language syntax, and how to use all the information from the existing shop floor to get a realistic trajectory between the simulation world and the real world, and how to get closer to the real world is what matters. So this is why RRS is important. How do we do RRS? There is an architecture behind RRS. Robot vendors implement a specific RRS specification within their controllers. So you have the real robot, which will connect to the real robot controller in the shop floor using a cable connection, and you will have a teach pendant where you will actually use the vendor logic and algorithms or heuristics between the different joint motions of the robot. What we do is we have the virtual factory or the 3D experience twin, where we have the virtual pendant, and the RRS application will sit or will be an add-on on the 3D experience platform, where the motion parameters will be respected from what is coming from the robot vendor logics and algorithms, and the simulation will follow exactly the same trajectory to give you more accurate cycle time. So once we have done the robotic simulations, we have to commission this in the real plant. In the real plant, we will have more and more automation, where we'll have example of kinematic resources like the conveyor or some material handling, and these will be driven by PLCs, where PLC program is very important when we are doing a real commissioning. So what we can do, we're using the robot virtual commissioning role within the 3D experience platform, is use RRS2 technology along with the PLC to validate the complete plant layout PLC programs. It's also important to notice we support both hardware and software in loop. What does this hardware and software in loop mean? For example, we have a PLC emulator that is a software. If you want to validate all the PLC signals IOs between two resources, we can use the software PLC emulator to validate the behavior, or you could use a hardware PLC, which will look like a box. I will show you in the next picture, where you can actually validate using an actual hardware that will be sitting in the shop floor in a virtual world. In this example, you see the picture that is a hardware PLC. What we are doing is we are connecting the virtual commissioning PLC system is connected to the robotic simulation with an Ethernet card. which will send the signals. All the IOS PLC signals are mapped between the simulation and the existing PLC. And also we support the human-machine interface. For example, you will have a sensor where the human should not enter. Once he enters, the simulation will stop. All this kind of use cases will be validated much early before you actually go into the shop floor to do the commissioning. So quick recap into overview of the benefits. First point which I would like to explain is fast and simple robotic work cell layouts. We have more than 1,500 or 2,000 robots that are available in the 3D Experience robotics library. If you have any special robots in request, we can always get it inside the library, provided the company, this is a company provided robot. Concurrent robot simulations, where we not just simulate a single robot, but multiple work cells where we have multiple robots, 50 plus or 70 plus, 75 plus robots working in the same time. The simulation engine supports this kind of simulations where you can have multiple robots working together. Improved collaboration between robot programmers and product or tool designers. Now we have to work with the other engineering departments where, for example, the fixture is designed by somebody using CATIA or other apps. How do we quickly collaborate with them? You don't have to export the data or import the data and send it to somebody via email. Everything is working in a collaborative, one unified platform. So this improves accuracy as well as time. The support of RRS2, like I mentioned, RRS1 is just motion and kinematics, but RRS2 is more taking advantage of the native program syntax and getting a more accurate cycle time. So we will support RRS2 also. And the capability to mix not just a robotic simulation, but also discrete event simulation, like my colleague Damiano demonstrated earlier, and use of ergonomics, virtual reality. This is just a area where we can see more and more traction using different simulations working with robotics. So that comes to an end of the robotics presentation. If you have any questions, please do ask me at the end of this presentation.
Thank you very much, Kartik, for your presentation. So now we will have Adriano and Özlem to give us a brief overview of a customer story that we have in Italy, and they will also summarize the entire session in a couple of minutes. So Adriano, can you please continue?
Thank you very much, Denis. It's a very pleasure to explain you the, let me say, success that we had in this Italian company that is called Ocme. And I cannot move.
You can control now, Adriano.
Okay, thank you very much. Okay, finally. Ocme is, as we told before, an Italian company that I followed as Delmia sales following the Euromed territory. I am the sales counterpart of Damiano in this case. And I like to speak about this company because it's a medium company in Italy, leader in what they are doing, meaning packaging, and in specific to package oil. They are producing machine to package oil for fry, crude oil for engines. They are leader in those kind of machine. They would like to grow abroad where the times to promise the machine ready is very, very important. They would like to continue to be leader in this market. And in particular, the issue that they had is to produce a prototype, because anytime their machine is a sort of prototype, as also for the wholesale integrators, anytime is different, fastly to win the competition. Because the customer is in China, they were really interested in simulating in advance mechatronic movement to define in a shorter time the machine to win the competition. That was the, let me say, the objective. And we did this, let me say, test and deal at the end in collaboration with ABB, that is, let me say, giving to this company the PLC and the equipments to control the machinery. I would like to speak about their challenges a little bit because is interesting and probably is the challenges that normally companies working in the domain of industrial equipment could have. First of all, they understood that digital twin important and they wanted to introduce absolutely the reduction of the time to market, because as of today, winning is also the time of the production. And what they wanted to do is also to test in advance the machine before to produce and check the machine with all the components, software for PLC too, before going to customer and implement the plant. Interesting things is also commercially use those kind of simulation Damiano spoken about, just to show to the customer before build your work cell and start to discuss with 3D data with your customer. Absolutely, the benefits was so important, and it was an important fair in Parma, in the Emilia-Romagna area, called the Kpis technology for food, meaning, and here there is coming from their CAD, the data, simulate, create the behavior with the cinematics, nothing different to the robotic simulation, but link with an intelligence coming from our solution to simulate the PLC, the controller behavior. Kartik spoken about that when mentioned virtual commissioning. Was a very nice, let me say, introduction to their offices, to the technical department. At the end, they were very, very happy. They bought the solution because we found really a benefit on that. I bring this example because we can have a few of those company maybe around, and could be again a concrete success of Delmia technology. I think Oslem is your turn. Thank you very much for your passion in following this seminar, and Oslem I think can conclude and wrap up.
Thank you Adriano. Merhabalar, ben Özlem Kayar. Dassault System Türkiye'de çözüm ortağı yöneticisi olarak çalışmaktayım. İş ortağımız Kadem Dijital ile birlikte gerçekleştirdiğimiz bu webinara katıldığınız için çok teşekkür ederiz öncelikle. Umuyorum ki sizler için verimli ve bilgilendirici bir etkinlik olmuştur. Etkinlik boyunca alanında uzman birçok konuşmacının farklı sunumlarını izledik. Sanal ikizler ve robotik alanındaki teknolojilerimizin şirketinize sağlayabileceği faydaları da kısaca anlatmaya çalıştık. Elbette ki bu alanlar oldukça geniş, kapsamlı olduğundan kısıtlı süremizde olabildiğince sade halleriyle sizlere aktardık. Tanıtmış olduğumuz bu çözümlerin şirketlerinize sağlayacağı değerleri de kısaca özetlemek istiyorum. Aslında faydayı 3 ana kavram etrafında değerlendirebiliriz. Bunlar da günümüz rekabet ortamında neredeyse her şirketin önceliklendirdiği verimlilik, tasarruf ve organizasyonel kazanım alanları. Sanal ikiz çözümleri üretim sürecinde veya son üründe karşılaşma ihtimaliniz olan problemleri sizlere en başta, yani tasarım aşamasında gözlemleme fırsatı veriyor. Çalışmaların ve metotların da tamamı dijital ortamda tutulabildiğinden hem şirket içerisindeki en iyi uygulamaların, yani tecrübenin kayıt altına alınıp saklanmasını, hem de kayıtlı dataların yeniden kullanılabilmesine imkan tanıyor. Bilgi kişilerden ziyade sistemlere aktarılmış oluyor. Bunun yanında çözümlerin sağladığı esneklikle birlikte müşterilerinizin değişen ihtiyaç ve taleplerine de daha hızlı cevap verir hale geliyorsunuz doğal olarak. Tasarruf başlığına gelirsek, en iyi ürün, en iyi son ürünü en düşük maliyetle çıkarabilmek yine rekabetçi iş ortamında ayakta kalmak için olmazsa olmaz koşullardan biri. Bu anlamda süreçlerinizi dijital ortamda simüle edebilir hale geldiğinizden hatasız haldeki son ürüne çok daha hızlı ve çok daha az maliyetle erişebiliyor oluyorsunuz. Yani deneme yanılma süreci ortadan kalkmış oluyor. Bunun yanında farklı işlerde kuracağınız iş istasyonları yani workcell'leri hazırlama ve son hale getirme süreniz de kısalıyor. Son olarak anlattığımız çözümler elinizdeki kaynak ve süreçleri dijital ortamda test ederek en verimli, en optimal şekilde kullanmanıza imkan tanımış oluyor. Rakamların yanı sıra şirketlerin başarıya ulaşmak için biliyorsunuz organizasyonel anlamda da dönüşmesi gerekiyor. Özellikle farklı departmanlar arasındaki işbirliğinin kalitesi hem iş süresini hem de yapılan işin verimliliğini ciddi derecede etkiliyor. Bu anlamda 3D Experience platformu içerisinde sunulan bu çözümler farklı departmanların veya şirketteki kişilerin tek bir ortamda aynı data üzerinde çalışıp son ve en güncel bilgiye en kolay, en hızlı şekilde erişmesini sağlıyor. Sadece şirket içerisinde değil, dilerseniz müşterilerinizi de dahil edebileceğiniz bir çalışma ortamıyla var olan bilginin tüm paydaşlar arasında kesintisiz ve en güncel haliyle transferini sağlamış oluyorsunuz. Toparlamak gerekirse bahsettiğim tüm faydalar sonuç olarak şirketinizin daha verimli ve daha etkili şekillerde çalışmasını, farklı alanlardaki maliyetlerinizden tasarruf etmenizi ve organizasyon içerisindeki tecrübenin korunmasını, bilgilerin kolaylıkla paylaşılabilir olmasını sağlıyor. Çözümlerimiz hakkında herhangi bir sorunuz, geri bildiriminiz olursa veya daha fazla bilgi almak isterseniz buradaki iletişim bilgilerini kullanarak bizlere dilediğiniz zaman ulaşabilirsiniz. Şimdi sözü iş arkadaşım Deniz'e bırakıyorum. Çok teşekkürler.
Ben teşekkür ederim Özlem. Thank you Adriana for the presentation. Şu anda sorularınızı alabiliriz. Birkaç dakikamız var. Eğer sorularınız varsa onları yan taraftan yazabilirsiniz. Bunun dışında Özlem'in de bahsettiği gibi bu konularla alakalı başka sorularınız varsa buradaki e-mail adreslerinden veya internetten bizi bulabilirsiniz ve istediğiniz soruları sorabilirsiniz. Biraz Türkçe, İngilizce biraz çeviri yapmamız gerekecek burada ama ilk bir soruyu soralım. Okay, I think it's Erwan's domain. Erwan, can you please elaborate if the 3D Experience Delmia is a scalable solution approaching step by step the domain we saw during your presentation? Can you hear us, Erwan? Okay, maybe
Sorry.
you're. Yeah. Did you hear the question, or should I repeat it?
Yes, please.
Okay. I'll repeat it. So the question is 3D Experience Delmia a scalable solution approaching step by step the domain we saw during your presentation? I mean, is Delmia scalable? This is the basis of the question.
Yes, absolutely. There are several steps in building a 3D experience twin, but depending of the customer need, it is not mandatory to have all steps and to buy everything at a time. And only plant layout can be used first to build a 3D model which is static. And later on, if necessary, it can be possible to add simulation capabilities, but it is not mandatory to use everything at the very first time. Does it answer the question?
Yes, I guess it answered. You answered the question very well. Thank you. So the next question is about the CAD integration. So I am a SolidWorks and CATIA V5 customer. Can I use Delmia 3D Experience with these CAD solutions? I think Ali or Damiano can answer this question. It's their domain. Can you hear us?
I can answer also. In fact, SolidWorks and V5 CAD can be used directly in 3D Experience platform to build the twin. It is standard. So
you say that we can use it with different CAD tools?
Absolutely, yeah. Additionally, a step can be imported, and also other CAD system can be used. Those other CAD system implementation are optional depending on the customer. If I'm SolidWorks, it is standard. You can use them directly in the
Thank you for the answer. Maybe one more, and if there's no other question, we can conclude the presentation. Okay, this is for Kartik. It's a question about robot integrators. So I am a robot integrator. Do you have libraries with kinematized robot in your solution?
Absolutely, absolutely. So what I would like to explain the question, the answer to this question is, we have a ready-made catalog of industry famous robots, maybe ABB, Fanuc, KUKA, or any industrial robot that you are using as a robot integrator. And we not only use the models just for the kinematics, but you also have the intelligence with respect to the kinematics heuristics. There could be some specific algorithm heuristics on the kinematic definitions between the behaviors of two joints of the robots, and also the soft limits and the hard limits. You know, the robot will basically have a servo motor on each joint, but we cannot use it to the maximum servo motor degrees of freedom, so that a mechanical failure will happen if we keep using it to the hard limit. So we also have a soft limit, and all this intelligence is included in the library so that you can use it for your robot integration work.
Thank you, Kartik, for this explanation. I think now we can conclude the event and all the presentations. I'm going to switch to Turkish, and thank you all. So, bütün katılımcılarımıza çok teşekkür ediyorum. Çok teşekkür ediyoruz ekip olarak. Umarız sizin için faydalı bir etkinlik olmuştur. Biraz uzun oldu, farkındayız, ama kayıtlı versiyonu Türkçe altyazılarıyla beraber önümüzdeki hafta içerisinde iş ortağımız Kadem Dijital'in web sitesinde bulabilirsiniz. Size zaten gerekli bilgiler iletilecektir. Tekrar izlemek istediğiniz bölümler olursa parça parça onları YouTube üzerinden izleyebilirsiniz. Bugünlük bu kadar. Tekrar teşekkür ederim. Hepinize iyi günler ve iyi hafta sonları diliyorum şimdiden.